Chapter 1 was pretty long. Don't worry, most of the chapters won't be that long. But we're moving now on to Chapter 2, which I hope you enjoy as well. Don't be afraid to comment and let me know if there's something that you need or that we're not touching on in the videos, or if you want the videos to be longer or shorter. So, hope you enjoy Chapter 2. So here we're starting out with an explanation for how the moon works, or basically how the phases of the moon works. So my guess is most people, just from knowing from being a geology professor, I know that most people have a pretty lousy explanation for the back of their head for how the phases of the moon work. So I want you to kind of like block some of those bad explanations out. Ooh, it's suddenly scary. The reason it's suddenly scary is because you probably, even if you learn the phases of the moon correctly, you probably have some kind of wonky ideas about the phases of the moon. Studies show that most Americans either learned how the phases of the moon works incorrectly, or at some point between elementary school and today, it got scrambled in their heads. So we're going to learn a little bit. We're going to look at a model that involves this light over here that I'm shining. Okay, and this handy dandy grapefruit. And whenever you get confused when we're discussing phases of the moon, come back to the grapefruit. So here is my beautiful, illustrious grapefruit. So off in the distance, I have a light. I'm going to notice that when I shine that light on my grapefruit, half of my grapefruit is always illuminated. So this grapefruit is basically getting cut in half, and the light over in this direction over here, okay, direction basically indicated by the sun's rays, is dividing the grapefruit in half. The sides that facing the light is lit up, and the side that is facing away, the side of the grapefruit that is facing away, is in darkness. Similarly, you can see this half of the grapefruit, but if I slice the grapefruit in half and consider the half that's behind my hand over here, you can't see beyond basically this curvature here. So we can see that we have basically divided our grapefruit into halves. We have this half of a grapefruit over here that is lit up, okay, and then we have this half of the grapefruit we can see. Now, this is going to pertain directly back to the phases of the moon. I want you, whenever you get confused about phases of the moon and what to sketch, think back to the grapefruit. All right, so here we have basically the same idea. So the sun's rays are coming from the sun way off in the distance over here. Now, we usually draw the sun like right over here and Earth to here, but this creates all sorts of angle problems that aren't really there. Because as we learned in the last chapter, the sun is way hella that way. It's one astronomical unit that way, which is equivalent to 93 million miles or 150 million kilometers. So it's way off in the distance. Because it is so far away, the sun's rays arrive parallel. Okay, so this is a time for you to get out your colored pencils. Now, does it matter what colors you pick for this stuff? No. Just pick colors that kind of say things like, for example, we're going to be doing shadows right now. And to me, this kind of like creamy light blue says shadow. Okay. We also want to make sure that we have a key. We're going to want to reserve some room up here because we're going to be drawing things like phases. So I'm just going to make a little area over here that's going to be my legend or key. Okay, however you want to phrase that. And I'm going to indicate that this color here that I'm picking, I want you to, whatever color you pick, I'm picking this like gray blue. You can pick whatever. This is going to be the shadow. Now, it's just like the grapefruit. At this phase, at this juncture, we are not coloring in our phases. Okay, we'll do that later. So, the side, and I've done 2 of these to help you. So 1 and 6 I've already done. The sun's rays are applying this way, just like the light was coming from this direction with the grapefruit. So we can divide the grapefruit in half into a half that is in shadow and a half that is lit up. So same too with the moon. The moon as a grapefruit. So this side is in shadow, and this side is in shadow. Now, I want you to think for number 8, how are you going to sketch it? Dora the Explorer thing, think about it. How are you going to shade in number 8? Excellent. So if you said this is the way you're going to shade it, straight up and down, that's the correct way to do it. So I'm just going to take my straight edge over here, and I'm going to do that to all my moons. These are all moons positions. We don't have 8 moons. These are 8 positions of the moon. Quick review, about how long does it take the moon to make its cycle around the Earth? Excellent. So if you said about 28 days, 29 days, good. If you're like, it depends if you're talking about a sidereal or synodic month. Good job reading the reading quizzes. But right now, we're just worried about a month, okay? If you haven't done the reading quizzes yet, that's okay. So it takes about a month for the moon to go all the way around. So these basically, this is the moon every about 3.5 days as it moves positions. Now we also want to indicate which direction the moon is revolving around the Earth. So the moon is revolving in this direction. So the moon revolves counterclockwise. Most objects in the solar system actually revolve they all revolve counterclockwise, and most rotate counterclockwise. So the moon revolves, in other words, goes in an orbit around the Earth counterclockwise. And also similarly, the Earth turns counterclockwise. Once again, we're leaving lots of room in here because we might need to put things, well, we will need to put things there. So the Earth is turning in this direction. It does that one loop. How long does it take? Correct, 24 hours. We're also going to shade in the Earth, okay? So if the sun's coming from this direction, how are you going to shade in the Earth? Dora the Explorer it. Think about it for a second. How would you shade in the Earth? Excellent. So if you said, I'm going to do exactly the same thing because the Earth is just another grapefruit, just another space grapefruit. So it's another space grapefruit, space grapefruits. The size of the grapefruit facing the light source is going to be lit up. The size that's facing away is in darkness. Now for the Earth, I'm going to label this. First of all, we're looking down here. So this is our North Pole. Okay, so we're basically looking down on the top of Earth. For Earth, what's this side here that's lit up called, and what's the side, like the part of the Earth that's in the sunlight, what time is it? You said daytime. You are correct. And over here we have nighttime. So day and night. Okay? Now, just like our grapefruit, we're in no way, this is still the grapefruit analogy. This grapefruit, just think of all these, when we're having all these discussions, we're going to keep going back to the space grapefruit. These are space grapefruit, okay? Just like our grapefruit, where we could only see, like when I've got my grapefruit here, my delicious grapefruit is here. I can only see the side that is facing me. Now, on the Earth, okay, you are standing on the Earth. We're actually going to draw little people on the Earth. I like to have, my observer is named Elliot. So I'm going to draw little Elliots around the Earth. So there's a little Elliot here, a little stick figure here. Okay. I'm going to turn this. Remember, Elliot's going to be, we want Elliot's feet, their feet facing downward and their head facing upward. So I'm going to draw little Elliots all the way around. Here's another little Elliot. And there's our last little Elliot. So here's Elliot all the way around the Earth. Okay, so I drew 4 little observers around the Earth. Now, as Elliot looks up at this Earth, position number 1, what is Elliot going to be able to see? Elliot is not going to be able to see, Elliot's going to see this side, but not that side. So I'm going to pick another color that means that that side, that part of the Earth is invisible. What color should I pick? I am going to pick... why is this so difficult, Chris? Why are you making this so difficult? I'm going to pick... Ooh, dark purple. That's pretty handy. That'll cover up the blue really nicely. So... this is going to be... Now, it doesn't matter what you pick. You can have magenta. I don't care. That's your business. But for me, dark purple is going to mean I can't see it. Or Elliot can't see. Or in other words, our observer from Earth. Okay? So, our observer from Earth can see this side, but they can't see the other side. So Elliot cannot see this side over here. Similarly, I've already divided number 6 this way. Elliot can't see this side over here. Okay, Elliot can only see that side over there. Now, I want you to figure out, Dora the Explorer, see if you understand, how am I going to shade the side I can't see for number 2? How am I going to black out? What part of number 2 can't Elliot see? Excellent. So if you imagine an Elliot standing here and looking upward from this direction, I can turn the page to make it easier to see. So if we imagine a straight line like this, it would be perpendicular, in other words, a right angle to that line over there. And we got this part shaded over here. We're going to keep going around. Keep going around. So notice it never changes the side of the Earth or the side of the moon that is facing the sun is lit up. The side that is facing away is in darkness. However, its position relative to us keeps changing. Okay, so keep doing this, going all the way around. This is why I have erasable colored pencils. Sometimes people mess up on this stage. This is okay. Like this. Now, a thinking person might say, Dr. E, I noticed a kind of weird thing. You have this side lit up and isn't Earth in the way. So this has to do with like thinking in 3 dimensions. Okay? You can have 2 things in a row and they're not lined up. So for example, the grapefruit and my fist, actually let's put it, so if the fist is Earth and grapefruit is the moon, grapefruit's like this, but if I turn the system, you can see that the grapefruit is above the moon. Or the grapefruit is above the hand representing Earth and the grapefruit representing the moon. So what's going on here is something really, really similar. The moon's inclination, okay, the moon's orbit is inclined. In other words, it's tilted. So most of the time, Earth and the moon are not in perfect alignment. So I'm going to put an asterisk by number 7 and an asterisk by number 3, and just add that note over here at the bottom. Same color. Okay. So I'm going to add the note that most of the time, the Earth and the moon are not in alignment because the moon's orbit is tilted, in other words, inclined relative to Earth's orbit around the sun. This is called the elliptic plane. So the moon's orbit is elliptic plane. The moon's, so you could say that the moon's orbit is inclined, or the plane of the moon's orbit is inclined relative to the elliptic plane. So let's go back to this diagram right here. So we're looking all around, okay? So we've got all these little Elliots, all these little observers standing right here. Let's first consider what they're probably seeing. So these are clearly not the phases themselves. So when I ask you on this question over here to give me this diagram, don't start sketching in the phases because you're just following along with the book and didn't watch the video very clearly about what the actual explanation is. So let's see what this Elliot sees. So this Elliot sees half, so this is the actual phases. This is what Elliot sees. So what Elliot actually sees right here, okay, Elliot is looking up. Half is in light and half is in darkness. And this is, so let's see, half a moon right here. When it's half lit up on the left-hand side, that is called a waning, or a third quarter moon. Now, same thing over here, but now we have to rotate what Elliot sees. So Elliot is still looking up, but now the right hand is lit up and the left hand is in darkness. So if we were sketching what Elliot sees, even though the same side is lit up from Earth, is lit up by the sun, it's still the same side that's pointing towards the sun. From Elliot's perspective, now this side is in light, this side is in darkness, and this is the first quarter moon. So, lots of learning here. Let's keep on trucking. Let's talk a little bit about positions of the phases and time on Earth and lunar and solar eclipses. So I have this really handy tool right here that helps me draw perfect little circles. You don't need this tool, but it is, I like it. I like having it handy. I find it useful. So what I'm going to do is I'm going to start off by drawing a nice circle that represents Earth. I'm going to draw Earth over on this side over here, and I'm going to make my Earth nice and big because I'm going to have to write all over my Earth. So, and I like Earth to be green. Earth feels green to me. It's not cooperating. Oh. There we go. So, not my best circle ever. Okay. The sun is still off in this direction. So the sun's rays are arriving parallel. I'm just having them come from the same direction. And I have it all the way over on this side, and we'll see why in just a few moments. So just like before, I'm going to have this represent shadow. It's split in half. Now, as I've discussed before, you don't have to shade particularly well. I assume that if you have gotten to college, you've gotten through kindergarten, and you know how to shade. So over here we have, this is our night side, and this is our day side. And the Earth is turning in this direction counterclockwise. Now, if the sun's over here, I'm going to draw my Elliots, draw them nice and small, rotate my screen like that, or rotate my sheet like that. Okay. And we think about these different Elliots. What time of day is it for this Elliot that's standing here with the sun directly over their head, or as over their head as it's going to be? So this Elliot is at noon. Now, the exact opposite time of day is what from noon? All the way on the other side, the furthest from the sun. Basically, the sun is on the opposite side. That would be midnight. Now, for these two Elliots, remember it's turning in this direction. So this one over here is at sunrise because it's going from midnight to noon. And over here, see, noon to midnight, it's sunset. So we've basically, by shading the earth this way, sun is on this side, shading is on that, we have turned the earth into a clock. I do want you to remember that this right here, this is the North Pole in this diagram. It's going to be different in later diagrams when we're talking about the seasons. So that's important because let's go ahead and think about, we're going to draw the moon further out over here. So this over here, this green guy here, this is our earth. What color represents the moon? I'm going to have a blue moon. We're going to have a blue moon over here. This is our moon. And we can see sun's rays coming from this direction, divide it in half. This is the half that Elliot can see as well, because this is the side that's facing away. We'll do it like that. And we can see that this would be what phase? The phase that we see, that bright side only facing Elliot, that's going to be our full moon. So if we go ahead and let's think this one through. This moon right here, if I draw straight down to this moon to Earth, I know there's a lot of turning of the page here. So this straight down, full moon. When the moon is in this position, this moon is straight over, or is at its maximum height relative to maximum angle relative to Elliot, okay, at midnight. So this moon is highest in the sky at midnight. Now, why do we care? Because this can tell us when that moon that we see, it rises and sets. So you can see, let's draw an imaginary Elliot. Let's add an Elliot. We're going to add an Elliot over here. Add this Elliot over here. We can see that just like we can divide the grapefruit into the halves we can see and the halves we can't. If we had an imaginary Elliot standing on, for example, this side of the grapefruit, they couldn't see us. But if they were standing on this side of the grapefruit, they could. So from this angle over here, this Elliot can see the moon. And this Elliot can see the moon. But the curvature of the earth is in the way between this Elliot and the moon. So this Elliot here can't see the moon. What's going on with that? That means that these two Elliots can see the moon and this Elliot can't. Now, what's an easy way to figure out what Elliots can see the moon? Well, we would find the rise and the set time. And the rise and the set time are basically 6 hours before and 6 hours after when that particular moon is highest in the sky. So So moon rise, so that phase's rise is equal to 6 hours before its highest in the sky, and phase set is 6 hours after its highest. So for this full moon, so full moon is highest in the sky at midnight. 6 hours before, the rise is 6 hours before midnight. In other words, 6 p.m. And the set is 6 hours after midnight, or 6 a.m. Okay? If you have to take a little bit of time in order to really understand this, don't be terribly shy. So, and then finally, lunar and solar eclipses. Lunar and solar eclipses are possible whenever they can be in alignment. So, for example, this is our full moon and this is our new moon. Because the new moon's in between the sun and the earth, okay, that gives us a chance of being an eclipse as well. It doesn't always happen because the moon's plane is tilted and it doesn't always perfectly line up in a row, but it could theoretically perfectly line up in a row. Same thing too for the full moon as well. Now there's going to be a lot more reading and activities, and you have a lab on it, so I'm not going to beat a dead horse on phases on eclipses, but hopefully this helps it make a little bit more sense. And then last over here, let's talk about the cycle of constellations. So these are really, so the full cycle of constellations takes 1 year. So a constellation is a named group of stars. And the Greeks got really creative in naming these groups of stars. So you'll see several memes about that as we go along. So this is pretty straightforward. Constellations go through a yearly cycle. So what's really going on, so let's suppose that we have the sun here. And people who have taken other classes with me will understand why it's the angry sun like that. And then we have 2 Earths. So this is Earth, Earth. Now they're on opposite sides of the sun. We know there's not 2 Earths. So what's going on here is this represents 2 time positions. So this is Earth in time period 1, and this is time period 2. These 2 Earths are 6 months apart, or half a year apart. Okay. Now off in the distance, I'm going to draw a star. We're going to call this star A, and this one over here, star B. So from this Earth can see star A, but not B, because the sun is in the way. Similarly, over here, B can see star B. So this Earth can see star B, but not A, because the sun is in the way. In other words, in this one, B is on the day side of Earth. And over here, A is on day side of Earth. So don't be afraid of sending questions. If the time thing with the moon is kind of confusing you, that's normal. Okay, that is really, really normal. So don't be afraid to reach out. Remember, your tuition dollars paid for me. So, and I'm here to help.